This is the Cloud Ace podcast, bringing you the latest in cloud security through captivating chats with fascinating cybersecurity experts who are leaving their mark on the industry. Cloud Ace is brought to you by the SANS Institute and hosted by SANS certified instructor Brandon Evans. And now, prepare for departure. We are cleared for takeoff. Here's your captain, Brandon Evans.
We have an absolute treat today. We have a panel of 3 of the top cloud identity and access management experts in the world on the Cloud Ace podcast today. Kat Traxler, Karl Fosaaen, and Kyler Middleton are incredibly knowledgeable about how IAM works in all 3 cloud providers. But Kyler specializes in AWS, Karl spends most of his time with Azure, and Kat is our resident GCP guru. Each panelist will represent their primary cloud's strengths and weaknesses. Which provider will come out on top? Will any cloud provider leave this conversation unscathed? You're not going to want to miss this. All right, so to get started, let's go around the panel and tell me a little bit about yourself, your career, and how you got into cloud security. So let's start with Kat.
Hey, Brandon. Thanks for having me on. My name's Kat. I'm the principal security researcher at Vector AI. I spend my days designing detections in the cloud for AWS and GCP, thinking about how attackers break in, how they move through the cloud control plane, and just where we can set those booby traps, where we can place those triggers to let our organizations know that there's some suspicious activity across their control plane. Prior to the detective side, I worked really heavily on the preventative control side. So I worked on designing IAM controls, pen testing in the cloud. And then even before that, I came into security in general through application security, working with an SDLC, working with secure code reviews, doing web app pen testing, that sort of thing. As my second job, I'm also the lead author for the SANS Sec 549 Enterprise Cloud Security Architecture course. It's a 2-day course right now. Stay tuned next year as it expands into a 5-day.
Awesome. And as someone who comes from an AppSec background myself, we have a lot of common with regards to that. I'd love to learn, and I will be learning a lot more about you, your experience on the detection side, because that's not an area that I specialize in. Let's head over to Karl now.
Thanks for having me on. So Karl Fosaaen, I'm a senior director at NetSpy. I've been with the company for almost 11 years now, and during that time, done a little bit of everything, application, network testing, social engineering, a little bit of everything. But more recently, and probably for more last 4 or 5 years here, I've led up our cloud pen testing team, primarily focusing on AWS, Azure, and GCP. But we do, all sorts of different clouds that come up with different client environments that we work with. I spend most of my research time looking at Azure environments and developing tools, processes, things like that for NetSpy to utilize as part of our cloud pen testing practice.
Awesome. And finally, Kyler.
Hey, everyone. Hey, Brandon. Thank you so much for having me. I work at Allscripts in the healthcare industry, and as part of their DevOps team, I'm just self-monikered cloud security chick, and thus the tiara. I just decided I could. I come from an infrastructure background, so lots of networking, Cisco Catalyst switches in my background, and consulting as well. And I've just been doing my best to evangelize IAM security, which is the backbone of AWS security. And it's JSON files. Everyone loves writing JSON for fun, right? So how to do it securely, how to scale it is a challenge and is the fundamental security of AWS cloud.
And I absolutely agree. I think it's funny that you mention people love to write JSON for fun. I actually do love JSON. I'm a YAML hater. I know a lot of people think YAML's easier to read. I don't particularly like writing IAM policies because those get very complicated very quickly, but I'm a JSON fan for sure. So to kick this off, I know that you all represent a lot of different clouds here, but Kat is our resident GCP expert at SANS. Karl has a lot of experience, as he mentioned, with Azure, and Kyler has a lot of experience with AWS. So let's kick this off by talking about, generally speaking, the philosophies behind these clouds' IAM capabilities. So let's go in the opposite order. Kyler, can you tell me a little bit about AWS's IAM philosophy, what's good, what's bad, what's consistent, and what's all over the place?
Absolutely. So I think it is comprehensive, but that can be a bad word in this case. IAM in AWS is JSON policies, so it's flat text, but there are several layers of authorization and authentication to get through to get to actually a principal doing an action. So several boundaries and organization-wide things that can stop you and make it work really well for your security posture or work really poorly because it's hard to figure out why this thing worked or where it didn't work. IAM in AWS world is a principal doing a verb against a resource, and filtering can be done at each layer. So both from the source principal and from the destination resource in almost all cases, which works great. The downside here, the huge gaping downside is tools like Terraform are so prescriptive and helpful for building resources and setting attributes. But for IAM, they just say, insert policy here. Good luck. Have a fun time. And that can be really challenging when you're getting started, particularly if you let humans configure policies, which you shouldn't, but almost everyone does. And it could get you in trouble.
Certainly. Let's head over to Karl now. Tell us a little bit about Azure.
So from the Azure perspective, they like to interchange the terms RBAC and IAM. So you'll see an IAM tab in the portal, but they use role-based access control for everything. So I'll probably use interchangeable terms there. But in general, I actually really like the Azure RBAC model, being able to take individual principles, be it users, app registrations, any kind of security principles within Azure and apply specific roles to them. I find it's really powerful and it's easy to scale a lot of those permissions compared to some of the other cloud providers that are out there. I feel like some of the policies don't always scale, and sometimes it's hard to kind of get a good grasp of who has what. And I think in general, Azure is pretty good about helping you identify who has access to specific roles, be it in the subscription management group level or comparative the Azure Active Directory level, which kind of a split responsibility. So that makes it a little bit more different than some of the other platforms that I've worked with. But in general, it's pretty good. That being said, some of the groups that you can utilize, those get nested and you get permissions that you didn't really intend to. Maybe you end up getting a much larger group nested within some other Azure Active Directory group. Then all of a sudden, pretty much all of your domain users have reader level access to a subscription. Not a good thing. Not super common, but have definitely seen it happen before. The other kind of bad and sometimes bordering on total mess of things, some of the built-in permissions for the built-in roles that are available for Azure can be abused. We've had a couple of situations where we've identified excessive permissions that would give us access through a specific role to identities or principles within Azure that have, say, contributor on a subscription. And some of those built-in policies have allowed for privilege escalation in the past. So I think Microsoft's doing a good job of cleaning those up from a built-in policies perspective, but those have been kind of a problem in the past.
Awesome. And finally to Kat.
I feel like I have, fairly aggressive opinions about IAM, specifically in GCP as it compares to specifically AWS, because that's my other cloud that I work in. GCP has this very strong concept of a hierarchy where AWS is it's completely flat. So permissions in GCP are all and should all be constructed around at which level you apply them. And so because there's such a strong hierarchy there, you need to understand which level you apply your permissions to, which then, informs the child resources. Applying, compute admin at the project level implies that you have access to all of the computes on that project, where if you apply compute admin at a single compute, only that compute has access. To me, it makes a ton of sense, but to some people who are coming from the AWS world, where there's not that strong inheritance model, it can be really confusing. And another thing I really love about GCP is that they completely work with resource-based policies. In AWS, there's this mix between identity-based policies where you can say like Bob has access to something, or who has access to the bucket. You can kind of go back and forth between identity and resource based. And like most of the confusion, I feel like, is between the interplay between those two. In GCP, it's all resource based. All you apply policies not to the individual, not to the user account, but you apply things at a resource. And that resource could be at an organization, at a folder, at a project, or at the individual resource. And then even below within the resources, sometimes there's further child hierarchies. So that's something I really love, is that there's not this confusion between these two ways of applying policies. There's just the one way. It's all resource-based. So I find it to be a much simpler model to understand, to scale. And then with some new tooling that they came out about a year and a half ago, you actually can enumerate all the permissions within your organization. Up until about a year and a half ago, that was a difficult task that required a lot of scripting.
Awesome.
And
Karl, you wanted to add something?
Yeah, I'll chime in on the hierarchy. Azure is very similar with management groups and subscriptions and resource groups and resources underneath that. And I really like the ability to apply different roles at those different levels. Now, from an attacker perspective, getting something at the management group level or root management group level, that's nice for us because that just cascades out through everything else. But same with Google, that hierarchy is really nice to work with applying those permissions.
It's really interesting in AWS how siloed the management of different accounts is. I mean, for IAM, but for everything too. Like all enterprises have dozens of accounts, and switching between them, I literally need like 6 incognito windows open because each one's in it. Like, it's very different from the Azure world of, I just have all my accounts listed and I can just go to them and assign permissions. So there's a lot of, I sure hope this JSON policy lines up from the source account to the dest account with the verb that I need against the resource. And that can be a pain. Then there's a better way. And it's how every other cloud is doing it.
Yeah, I feel like that was like AWS's original sin, right? Of thinking that the account would be like the highest level resource you would ever need. Mm-hmm. But when they created that was all they needed. They had never dreamed that an organization would need hundreds or thousands of accounts and you'd need a hierarchy above it.
And the AWS organizations are coming with hierarchies, but I think they're trailing, which is an interesting place for AWS to be.
It's all very shoehorned in too. Like it works, but it's all just building off of the existing mechanisms like roles and assume role policies. Like there's automated tools like Identity Center and some of the permission sets to make it kind of look like a hierarchy, but it's not in the end.
Absolutely. And I noted, sorry, Brandon, I noted when Karl said you run a report against a specific resource. In AWS, that doesn't exist as far as I'm aware. I'm sure someone will teach me if it does. But mostly it's a principle-centric view of who is initiating the action. And if you want to say, like, here's a specific resource and it doesn't have a policy, who can talk to it? Who can do an action against it? Good luck. You'll need a third-party tool, as far as I'm aware.
Yeah, you might be able to detect who's using what just by analyzing CloudTrail logs. But that's certainly not as ideal as being able to, without a third-party tool, determining who has access to what. Absolutely. Awesome discussion. And yeah, 100%. Amazon is behind because they took a really long time to implement organizations. I believe they came out with organizations in 2017, which is 11 years after AWS really got onto the scene. And yeah, not only is it important to have multiple AWS accounts organizationally, but it's also a great security concept of having your objects, your resources in different accounts so that if you, for whatever reason, apply way too many IAM permissions in one account, that's not going to result in everything getting blown away in another account. But organizations are here now, and we do have organization service control policies that allow us to mandate the maximum amount of permissions that someone can have within an organization. But are there any pitfalls that AWS has with regards to organizations? Does it do a relatively good job, or are there pitfalls because organizations were retrofitted on top of traditional IAM?
There's a couple pitfalls. Some of them are pretty minor, but some of them are significant. One that's pretty minor is that the account needs to be created before it is assigned to a hierarchy. So you need some sort of construct like a Terraform or a CloudFormation to build your account and then assign it somewhere, or you have to manually drag and drop, which is no fun at enterprise scale. And one of the other pitfalls that you can run into is SCPs take effect immediately, and they are enforcing and they are blocking. There's no, log only, monitor only mode for SCPs. They're just right away effective. And if you see something break, you roll it back. And hopefully that doesn't interrupt your operations, but it certainly can.
Certainly. And yeah, it's really difficult to drag and drop, like you mentioned. We talk about this a lot in Sec 510 and Sec 540, but you really want to have your infrastructure automated using something like Terraform. And one of the cases in which I learned this firsthand was actually with regards to breaking up a ginormous AWS account into multiple different accounts. And because so many things were manually created, we had to go back and actually create infrastructure as code to create those environments, which was a nightmare. It was terrible. I'm already having flashbacks thinking about it. So if nothing else, hopefully hopefully this story shows you that you really want to be doing infrastructure as code from the get-go. But yeah, it's definitely quite complex. Now, in comparison, Kat, just GCP is so much better in this regard, right? I mean, just the hierarchy is incredible.
Yeah, GCP is pretty amazing. What can I say? No, it's always been considered a first-class citizen, right? Like the org has always been considered, your first stop, followed by your folders at, I think up to 30 folders deep, but don't do that. Followed by, thousands of potential projects, and moving resources between projects is possible, and moving projects between organizations is even possible. So, I think that there was a lot of foresight when they created GCP to think of this strong model, the strong hierarchy, as being a first-class citizen. It wasn't tacked on afterwards. So it really is just, a hierarchical construct that you can work with, and you need to leverage to, map out all your resources and have it be in a way that you can apply policy to effectively. Certainly.
One thing that is frustrating, though, with GCP is that in order to use an organization, you have to have a Google Workspace or a Google Cloud Identity subscription. And that seems pretty reasonable for an organization to have to set up. I mean, that's totally normal. But in my experience, I'm curious if you've seen the same thing, oftentimes GCP ends up in my environment because someone was trying to create a shadow cloud account, shadow IT, and avoid some of those organizational controls that are being implemented, let's say in my Amazon or my Azure account. So I often find that projects end up being created outside of that organizational hierarchy. Have you seen the same thing? And if so, is there anything we can do to fix that problem?
Yeah, so I think it's exceptionally reasonable that you have to have a G Suite, a workspace account, or a cloud identity subscription in order to work within GCP. They're really strict about considering that authentication is handled outside of the cloud platform and authorization is handled within it. So your users, your service accounts your users are not going to live within GCP. They're going to need to reside somewhere else and then be authorized in. So I don't fault them for that. What I do fault them for is sort of the default behavior of Workspace, in that your users can create projects. So that shouldn't be a default behavior. That users in your GCP workspace can go ahead and create projects. I think that's where we get a lot of shadow projects from.
And Kat, is a project a folder within an account? I'm new to GCP.
Yeah, the project is equivalent to an AWS account. So let's say your company has G Suite, has Google Workspace. Without your workspace admin taking action and preventing it, all of your users have the ability to go to console.cloud.google.com and spin up their own projects and create their own resources. So yeah, less than ideal. I don't think that should be the default behavior, but I think in this case, whoever really wanted quick adoption won on that front.
Yeah, Google has a bit of a hierarchy, like you mentioned, organization folders, then projects, then resources. Azure has a lot of layers of the hierarchy. You want to walk us through all of those different parts, Karl?
Sure. So I think it's a common misconception for a lot of folks with the difference between Azure Active Directory and Azure. So Azure Active Directory being the identity provider and typically having a tie-in for more traditional Active Directory environments. So we do see a fair number of just pure Azure Active Directory, never touch an on-prem domain controller kind of environments. But a lot of the clients that we work with are migrating from on-prem Active Directory up to Azure Active Directory. And you can think of that as just your base identity provider for Azure as a cloud provider. So Azure being the cloud provider underneath Azure Active Directory, you've got management groups at the very root. So everybody has a root management group, even if you just have one subscription. And underneath the management groups, you can have child management groups and then subscriptions underneath that. And then that hierarchy can really branch out from that point. I think they nest up to 250 layers, something like that. So you can get really, really complicated with your Azure account or Azure tenant structure. So it kind of goes all over the place. And to tie it back to the role-based access control, you can apply any of those roles at any of the different levels. So management groups, child management groups, subscriptions, and even below that, the individual subscriptions, so on par with projects or accounts for GCP or AWS, these subscriptions have resource groups and resources underneath that. And you can apply roles at every single one of those layers. So it does get a little bit complicated, but the resource level granularity and kind of tiering up from that is really nice.
Certainly. So one of the things I really like about resource groups is that you can just wipe them out and get rid of all of the resources underneath there, which is very important for my use case, which is creating lab environments. With AWS and GCP, well, GCP is not bad. You just get rid of the project. And I guess you could close down the entire AWS account. But if you want to get rid of all the resources within this portion of your Azure account, it's really, really simple, I think, in comparison to the other providers. But yeah, there's a lot of levels there. 250 levels within Azure.
I think it may nest up to like 255, something like that. I'd have to go back and double check it. But yeah, you can get pretty deeply nested in that structure.
255, wow.
I love the resource grouping in Azure subscriptions for that very purpose, Brandon, to blow away things, to just say that, like, to have a collection of things that I'm working on for an experiment or for a project. And there's a lot of like co-locating of activity in subscriptions. We're not perfect. We co-locate subscription stuff all the time. But just to say, like, this circle of things is alike, and then I can just blow this stuff up, metaphorically.
Yeah.
So I was working with an Azure architect and I was showing him AWS and he said, oh, well, how do you group resources in an AWS account? And I was like, I don't know what you're talking about. That's not a thing here. I'm so sorry.
Tagging, maybe?
Yeah,
Maybe
that's the best
tagging.
solution I could think of.
Yeah.
But even that's not super efficient. I can't think of a way of grabbing all of the tags for something and then like massively deleting something all at once.
I guess you could script it, pipe together a find against every resource type, but it's certainly not as intuitive as resource groups.
Yeah, we have so many developers just not doing anything in our organization that could set up those scripts. Like, we definitely, that's definitely a suitable solution in comparison to the other ones where you just click. Of course, right? We have so many people just here to write scripts, right? No, I'm with you. Yeah, there's a solution for all these things. Like, vendors love to say, oh, we have an open API, so you can just fill in all the gaps. And I'm like, that's not a suitable response. That's just you telling me to do your job. It's kind of funny to me how the cloud providers get away with this, as well as a lot of other vendors, but I'm not going to belabor that point too much. There's probably a lot of people working for vendors in this podcast. Sorry. But one thing, I'm trying to figure out how I can phrase this question without giving the game away. But in terms of policies that exist in AWS, Azure, and GCP, all three of them give you some built-in policies. Karl mentioned that Azure's built-in policies do have some inappropriate actions that are baked in with the different types of roles and permissions that are there. But I would say, Azure generally does a decent job when it comes to those built-in roles. And we'll talk more about primitive roles later with GCP, but that's a whole other conversation. But in AWS, should any customer be using an AWS managed policy? Is that a good idea, Kyler?
Oh my goodness, no. I feel like we're really beating up on AWS. They had that first mover advantage, they invented some cool stuff. But no, absolutely not. I think there's something like 1,000 built-in policies that you can use, and they demonstrate how to grant access to things, but they don't often answer why, or how should you scope this down. You can target every policy against specific verbs and specific paths sometimes, like inside S3 buckets, inside IAM. But often the how and the why is not covered very well unless you read the 1,000-page document of how to do everything in IAM. And I'm working with our AWS TAM and some other AWS engineers to expand the prescriptive resources AWS has about how should you really do it? Like, here's how it works, but how should you really do it? And that kind of stuff is just pretty nascent at this point. So hopefully they build it out because, don't use the ones that are built in, least privilege, target everything, verbs and resources. Yes, please.
And it's just so frustrating to see that with AWS. Like you mentioned, the scope in particular is problematic. AWS does grant too many actions in some cases. And in some cases that I've heard of, and you're welcome to mention stories of this if you've experienced them, I hear that there are some AWS managed policies that get permissions added to them without the customer realizing it, and that those can sometimes be problematic.
Support for the Cloud Ace podcast comes from the SANS Institute. Major enterprises are now multi-cloud by choice or by chance. Vendor-specific training only covers one cloud provider at a time. Sec 510 Public Cloud Security, AWS, Azure, and GCP is different. It explores the strengths and weaknesses of the big three cloud providers in depth, exposing insecure default configurations as well as inherent security issues that cannot be directly mitigated. By completing over 15 hands-on exercises that cover each major cloud provider equally, Sec 510 students develop a deep understanding of the underlying design and implementation of the providers and their services in order to secure them appropriately. Continue your journey in cloud security by visiting sans.org/sec510. I look forward to having you in class.
But the biggest thing for me is that resource clause. But did you want to mention an example of that you had on hand?
There was a recent example that it was an S3 bucket reader policy that was supposed to grant only metadata, and it actually, one of the built-in policies granted access to all of the data within all the S3 buckets, and it was a silent update that was just deployed. And they rolled it back in a matter of hours, but for a little while, everyone that used that built-in policy could read all the files on all the buckets, and that's not good, especially in the healthcare space like where we are, but just not good.
Yeah, and is that related to this one policy relating to AWS support? I believe that there was a policy for AWS support teams that somehow they got S3 read-only access.
Yep, absolutely. And that's, it's great when support has the access they need to help you out, but it's not great when they can look through your files.
Absolutely. The resource clause, though, as bad as those problems are, that resource clause just drives me up a wall because it's almost always star. Because how could AWS possibly know what buckets are sensitive and what buckets are not sensitive? How could you possibly know that? You can't. You cannot possibly know that. So you have to put it down to particular resources. Now, the beautiful thing about Azure and GCP is you can have those built-in roles, but then assign them to a particular scope, bind them to a particular resource in the resource hierarchy. And now, basically you could reuse their built-in policies as long as you're using ones that don't have any known issues and that you're using the appropriate scope.
Yeah, I mean, I think applying a GCP predefined role, say, to a bucket is equivalent to applying an AWS IAM managed policy to a specific S3 bucket, defining it within the resource scope. So they're equivalent. Like, you can achieve the same goals. It's just more intuitive, I think, in GCP and probably Azure as well, when you have that hierarchy, that strong hierarchy that encourages to apply at resource levels.
I think the tricky part is getting people to apply them at appropriate levels. With a lot of the clients I work with, it's all the developers get contributor, meaning you can modify, delete, do whatever you need to with any of the resources at the subscription level. So pretty much all the permissions that we see are typically applied at subscription level and not down to resource group or individual resources. We have a handful of clients that are really good about it and scope things down appropriately for smaller buckets of things. But, hey, you're a developer? Okay, cool. You've got contributor across prod, dev, non-prod, all of these different subscriptions.
Yes, and certainly this can be abused. Certainly you could be using these controls inappropriately. But correct me if I'm wrong, Kat, I believe there is a difference between giving the policy to a particular S3 bucket, because then you still have to specify the members, the principals that can access that S3 bucket. And AWS also cannot predict which principals should be able to access that bucket, right?
I don't think I'm tracking with you. So in GCP, you would say on the bucket, Bob can get data. And then in AWS, you would say you'd have a resource-based policy on the S3 bucket that said Bob can get data. So I'm seeing like you can achieve the same goals. It's just a little bit more intuitive because GCP is pure resource-based policies, and there's not this conflict between identity and resource-based.
Yes, I agree with everything that you mentioned, but the big thing there is that you'd have to specify the principles in your IAM policy itself. Whereas, correct me if I'm wrong, if you attached an AWS managed policy to a resource, is that even possible? Can you attach an AWS managed policy to a resource, or is that only for IAM principles? Got it. Okay, so I guess that is not possible. But let's say if there was an equivalent to that in AWS, right? In AWS, their managed policies do not specify the resource, or in fact, they explicitly say resource star. So if you did the equivalent of that on an S3 bucket, sure, the resource would be implied, but then who are the members? Who are the principals that can actually access that resource? So I feel like with GCP and Azure, you have to be way more explicit. Wouldn't you agree?
Maybe.
Okay.
I might be tracking you. I think setting the predefined roles, the managed policies aside, I think that's maybe where we're getting caught up. But the same goals can be achieved on either one. It just depends on whether or not working in that particular cloud, you're accustomed to applying at the lowest level possible. And just hearing Karl mention, how he's coming across tenants that have, everything's applied at the subscription level, right? Everything's applied at these like high resource levels. And that was always my biggest no-no when doing reviews of GCP projects was if I saw anything other than some just basic read-only permissions applied at the project level, those were immediate findings because everything should be applied at those resource levels. Because the most important thing you're looking at is scope, not even necessarily permissions or actions, but how are you scoping the resources?
Absolutely. There's nothing that you are restricted from doing in these cloud providers if you're doing things properly. If you do the research and okay, I shouldn't use AWS managed policies, I should scope down to particular things, I should not use an Azure role-based access control to apply the entire subscription, and definitely with GCP, those project level permissions are highly problematic. A lot of people read the docs, but probably not most people. And that gets me to one of my favorite topics, which is default policies, default permissions. Now, as I understand it, in AWS, if you launch a brand new VM, no permissions. Azure, you launch a brand new VM, no permissions by default. What about GCP? What happens in that case, Kat?
Oh, the worst of all worlds, right? The compute instance or AppSpot instances are assigned the editor role at the project level. The service accounts associated with those compute instances. So pretty horrific. I can only think that Google is allergic to friction because they just want it to work. Fortunately, there is an org policy, which I encourage everybody to apply today, that can block that default behavior.
And just to put a bow on it, the editor role, it's so powerful. It literally means you can do anything in your GCP project except for modify billing and changing IAM. Is that right?
It's equivalent to contributor in Azure. I mean, it's it's a notch down from full admin.
Yeah. So imagine in Azure, you launch a brand new VM, no additional configuration, and that VM has the contributor role. What kind of things could go wrong there?
Well, I'd say that's on par with the automation account run as accounts that used to be kind of the standard for automation accounts within Azure. So kind of the serverless code automating a lot of the functions in Azure, you can utilize built-in run as accounts. And initially when those were set up, and Microsoft's migrating away from those, really encouraging people to use managed identities instead. But those run as accounts defaulted to contributor. And we've found a couple of different ways to get access to the credentials. So typically a certificate for that run as account to extract those out of the automation accounts. There was an issue with the manifest within Azure Active Directory that was storing those PFX files up in clear text format that anybody in Azure Active Directory could read. That was a bad one. But yeah, equivalent to the GCP kind of example, automation accounts and the run as accounts attached to those, definitely very similar. Thankfully, no default managed identities or anything else tied to Azure virtual machines whenever those get spun up.
I would argue.
Go ahead. I'm in disbelief that that's the default permission. Oh my goodness.
And just to give some more context, because it's so mind-boggling to even think about, is that if a virtual machine has the contributor role or the editor role, that virtual machine has permission to launch other virtual machines. How absurd. Why would that be the default behavior of an application VM? That's just wild.
He said, somebody's very allergic to friction. It's a 4-letter word over there.
Is that like a GKE clustering kind of thing? So you need to spin up other nodes of a cluster, or?
There's probably lots of kind of like legacy paths reasons why like that an EC2 instance would be helpful if they just had access to everything. A lot of the legacy paths, like the data flows and data procs of the world, they all just ran on computes. So having the compute instances have those permissions probably just made it all work.
Well, I never even considered that. That's really interesting.
Yeah.
I just thought it was, hey, let's get the customer up and running as quickly as possible. Let's not lock down anything by default. And it wouldn't be particularly unique for them to do that in IAM versus networking, for example, because their network rules are also quite wide open by default. Yeah, it's quite wild for sure. So you mentioned about getting permissions, escalating your permissions with the run as. By the way, I'm not familiar with that capability, so thank you for mentioning the run as, you said, Azure capability.
Yep.
So you mentioned how you can basically get the permissions for that concept using PFX files, using a certificate. Now, for IAM today in AWS, Azure, and GCP, we have what's called the Instance Metadata Service. And I feel like no conversation about IAM in the cloud would be complete without talking about IMDS. So does anybody want to give us a little intro to what IMDS is all about? Not everybody at once.
I can talk a little bit about it. So it's in the AWS world, each EC2 instance, anything that has an ENI, a network interface, and a VPC, can call a 169 address and get back a web response of a whole bunch of information about the account number, the name of the host, the all sorts of metadata about the individual instance. Is that what you're talking about, Brandon?
Yes, and what's in that instance beyond just basic metadata is credentials or some kind of token that allows you to authenticate to all these different PaaS services. So the IMDS is such an under-discussed topic. Anybody else have any thing to follow up there with?
Not to say anything bad about AWS, but I feel like GCP and Azure have a little bit of, a benefit of requiring specific headers for calling the IMDS versus AWS. If you're using V1, you could potentially SSRF or server-side request forgery IMDS tokens out of AWS EC2 instances or other services through SSRF. With Azure, you're required to have specific headers attached, or depending on the PaaS service that you're working with, there's certain environmental variables that you can utilize to request those specific. Azure uses JWT or Java Web Tokens that you have to scope specific resources to. And it's a little bit of a different process, but same idea. You hit a metadata endpoint and get a token back and use that token back with APIs. So a little bit of a benefit of requiring those extra bits of authentication from an Azure and GCP perspective, but AWS is improving on that.
Yeah, I feel like GCP and Azure are the most rational defaults at this point. By default, requiring the header with their latest and greatest metadata services. That wasn't always the case for GCP. They had legacy metadata services that took them a long time to shut down. But I do think that for those who really want to lock down their metadata endpoint, AWS actually has probably the best security controls you can implement if you're aware of them and you're on top of specifying the number of hops that are allowed for the token. I don't know if you want to chime in on that, Kyler.
In terms of past role, is that what you're talking about?
Oh, I was referring to specifying the number of hops the token's allowed to make from after being generated. 1 hop, 2 hops, 3 hops, to prevent a token from being extracted and then being replayed over and over again.
No, that's totally new to me. Please take it away.
And it gets really confusing because these are 2 different tokens we're talking about.
Yeah, if you want to go ahead, Brandon, I'll just Google it real quick here.
I've, for better or worse, I've had the opportunity to talk about this like 700 times. It's the first topic we talk about in Sec 510, and it is a quite advanced topic. But as mentioned before, you can talk to that instance metadata service to get the credentials for a virtual machine. And by default, with AWS now and with GCP in the past, you would not need to include any headers of any kind. And this was really problematic because of the Capital One breach that happened in 2019. So there's a lot of details on this. We can add those to the show notes. Eric Johnson, who's my co-author, actually did a great write-up about this before we launched Sec 510. But there are some controls now you can apply because of that breach for AWS. One of them is the one that Kat mentioned about having a time to live on the token that you use to talk to the IMDS. So they added a new token for IMDS that you'd have to include in all of the requests, which prevented some server-side request forgery vulnerabilities. They also required you to generate that token using a put request, which blocked a lot of different open proxies. And the one that Kat's mentioning is how that token can be limited in terms of how many IP hops it can make, so that if you have a network load balancer and you try to get the token from the VM through the network load balancer to some external place, it would block that. Because it would only be able to move from one IP node to another, and then it would time out, and then it would no longer be usable. Did I miss anything, Kat?
You covered way more than I was even thinking about. When I think about instance metadata too, I think of the hop limit. But then also, you mentioned the TTLs you can add, which are advanced controls that I don't know how many people really use.
Not many.
They're not available in GCP. But as far as I know, only AWS offers those to their customers.
And it's extremely frustrating because AWS told us that this was a defense in-depth mechanism and that the original AWS IMDS is completely secure and will continue to be supported. And they didn't mention Capital One once in the announcement of IMDS v1, which I think is kind of disingenuous, honestly. But they're in a tight spot, like you mentioned. The defaults are there for a very good reason, which is that if you change those defaults, a lot of things would break. Because the way that your applications talk to the IMDS is via your AWS SDK. It does this transaction behind the scenes. And if you have an AWS SDK that is older than the IMDS v2, it just won't be able to get the credentials it needs to talk to any of these services. No one really understands this outside of security wonks like us. The developers certainly don't understand this because they don't look underneath the hood. And not only is AWS not advertising this, I don't even think you can change the setting in the AWS console. You have to use Terraform or the command line. So it's really terrifying stuff.
I actually just created an EC2 today, and you can change it. I think it's under like some expandos. You have to really dig into it, but yes, you can flip it to IMDS v2 and then configure your TTL and your hop limit in the console. But you have to kind of dig.
That's great news. I know that the last time I checked, you couldn't update that setting. Maybe you can set it when you're creating it. I really hope that they make this more prevalent because it's a horrible default. But with infrastructure as code, you're spinning up new VMs. People are going to have things break if they don't understand that the default has changed. It's really a problematic situation. Also an advanced topic for sure. Kyler, you wanted to jump in?
I have a quiz question that I don't know the answer to, but I'm curious about how Kubernetes manages that service. Does it have a listener within like an AKS or an EKS that forwards to that service natively? 'Cause I have no idea.
Maybe they're not using v2.
So curious.
Is there anything like that in AKS, Karl? Do you know of how that works within Azure?
So for getting credentials within AKS and Azure, you have the option to use a service principal or using the managed identity tied to the cluster for AKS. I see a mix of both. The one downside that I guess I would call out with utilizing an app registration or service principal on the AKS cluster is that those credentials get stored in clear text in a text file on the cluster itself. So if you have rights to run commands on the virtual machine scale sets that run the cluster itself in AKS, you can actually extract the service credential or service principal credentials out of that cluster. So it's kind of a mixed bag. With anything, clear text credentials, not recommended. Utilizing the managed identities within Azure, it's a lot easier to just apply the rules that you need for the managed identity itself. But that being said, you can still generate, that JWT for the service if you've got command execution there as well. So it's kind of 6 of one, half a dozen of the other. Do you want clear text creds or a temporary token that you can get out of the service as well? So they've got a couple of different ways.
I know in GKE, there's some mapping between members in GCP to Kubernetes principles. Am I getting that right, Kat?
Yep, you're referring to a workload identity. I think that in the AWS world, people would be familiar with like the AWS auth config map, which is just like a text file mapping. In GCP, it's actually an OIDC provider that maps and authenticates the Google principles into the Kubernetes cluster. Now that's separate than the actual pod level metadata service. So we've kind of been talking about the metadata service for EC2 instances. You also can have a separate metadata service just for a pod. So it actually doesn't call the node, it calls a separate instantiation of the metadata service. So it's not retrieving that same endpoint that all the other pods would be calling.
One thing that I like about AWS and GCP, relatively speaking, is I think that their controls in IAM are relatively consistent. In Azure, I've noticed that there's a lot more inconsistency. And one example of this is that, for example, you cannot read data from an Azure Key Vault without using a separate Key Vault access policy, or at least until recently. I hear that there's some developments in that space. Are there any other types of resources that you cannot access using role-based access control, Karl?
I'd have to think. There are specific concepts for a lot of different resource types for private networks or private nodes that you can use, so that it restricts the networks that can access the actual resource itself, or a private endpoint, I believe it's the proper term for it. And that's one way to kind of restrict it. It's not really tied to Azure RBAC necessarily. I believe that Key Vaults are really there's other services that would have additional kind of service level roles, but that's really tied to the individual services. From a platform perspective, the Key Vaults really have to have the access policy access. That gets kind of negated if somebody already has contributor on the Key Vault, because then you could just change the access policy and grant yourself access. We've done that multiple times to get access to a secret, where we have contributor and we don't have access to one of the access policy users, so we just temporarily add ourselves to the list, get the secret, remove ourselves.
Yet another reason why having those high-level permissions at the subscription level are just so problematic, because even if there's something you can't access using IAM, you can probably use that IAM permission to escalate your permissions. And the same is true for all of these providers. Now, I know that we're coming up on time, but that reminds me of another interesting topic to conclude on, which is that everything we've really been talking about so far has been platform as a service, being able to authenticate to a managed service from one of these three cloud providers. But when it comes to infrastructure as a service, it doesn't quite work like that. You can use IAM to administrate infrastructure as a service. But for example, if you want to access a database that's running on an RDS instance in AWS, or Google Cloud SQL in GCP, or one of the 700 different database services that exist in Azure, if you're running MySQL, you need to use a traditional MySQL user and password. Are there any other areas in which the credentials don't even map properly? Or SSH users, Linux users, another example of this.
I think from an Azure perspective, a lot of the services have started integrating Azure Active Directory into it, so you can join something to an Azure Active Directory domain. There's better support for getting those virtual machines automatically joined to an Azure Active Directory tenant and managed with Intune or device management kind of options with Azure Active Directory. Other services like Azure SQL have built-in Azure Active Directory integration, so you have some management over that. But I would say with a lot of the other database services, like you mentioned, it's username and password. You got to generate those on a per user perspective. Where do you store those credentials? How are you managing those credentials? Things get really messy.
Anything similar like that in AWS or GCP outside of just those traditional databases that you could think of?
Yeah, definitely the SSH keys. You can create an SSH key per host, but that's not what I've seen in the real world. I've seen one key per account per region shared among hundreds of hosts, and that is really a terrible way to run things. There are many tools that permit you to get just-in-time access to hosts or pivot through a bastion host, and sharing SSH keys. Please don't do that, because it's a terrible operational model. And I have seen, this is a recent development, RDS SQL does support IAM authentication into the host recently. It's very new, and I think it kind of works even, which is exciting. And the big one that I'm focused on recently is Kubernetes. It's treated as an application, so they draw the line under it and really don't extend their permission model into it at all, which is really disappointing so far. And I hope they improve it.
Yeah, mapping IAM into Kubernetes is the last frontier, right? It's like goes through a fun house machine and goes wah 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 wah, and then it comes out the other side completely different. We've spent an hour talking about IAM, but the bane of my existence is access control lists, which is long before there was IAM, there was access control lists. And that exists in AWS, that exists in GCP. It's just an alternative mechanism for granting access, specifically in GCP to buckets, where you can specify an owner. See, I have this pulled up so I don't get it wrong. An owner, a writer, or a reader onto the buckets, and then say somebody can have that owner ACL, that owner grant via their Gmail address, specify a G Suite domain identity, specify a Google group identity, or list one of these predefined groups like all users or all authenticated users. So it's this like under the radar access that, oh, by the way, isn't affected by org policy, because org policy constraints apply to IAM. This isn't IAM. These are ACLs.
Yeah, there's a lot of messy things underneath the hood, a lot of legacy concepts. I did not know that you could authenticate to an RDS host with IAM as of recently. That's news to me. And I know in GCP, we also have something called OS login, which allows you to translate IAM to SSH keys. So it's going to take a while to get rid of some of those legacy concepts and really bring them under the fold of Cloud IAM. But I, for one, am relatively optimistic, just not as optimistic about the timeframes.
So small personal gripe about Azure Active Directory, virtual machines, identity, all of that. We frequently run into backup domain controllers running as virtual machines up in Azure. So anybody that has contributor on those virtual machines or virtual machine domain controllers has domain admin. You can run system level commands on the server itself through run command, any of the VM run command options that you have out there, and effectively make yourself domain admin on a domain that typically is tied back to Azure Active Directory. At that point, if you can, DC sync up with the domain controller, dump out all of the hashes, and potentially crack hashes and get access to other accounts in Azure Active Directory, it really breaks that whole Azure Active Directory permissions model. So we really recommend that people segment off all of those domain controllers off into completely separate subscriptions and keep those away from everything else, because way too often we see just everyday accounts for developers that have contributor on a domain controller.
So maybe extending IAM into applications isn't all flowers and puppies.
Yeah, we're unfortunately going to have to leave it at that nightmare for our audience to think about. Hopefully not keep them up at night. But oh man, this was an awesome panel. I'm so glad to have had you all. Before we head out, do you want to plug your social media for the audio? Kyler, you want to get started?
Yeah, absolutely. So I am a frequent speaker at conferences and a blogger. I have a Medium that's very active. You can find me at Twitter at KyMid, or Kyler.omg.lol is my hilarious web home.
That's incredible. Karl?
You can find me on the NetSpy blog. That's just off of netspy.com. I'm pretty frequent contributor, primarily Azure-related stuff up on the NetSpy blog. You can find me on Twitter at @KFosaaen. That's me.
Awesome. And finally, Kat.
Yeah, you can find me on Twitter at NightmareJS. When I have blogs I want to put up, I put up on my personal blog. It's entitled Taste the IAM, kattraxler.github.io, and occasionally I'll put some blog posts on the Vector blog.
Excellent. And we'll make sure to put all of those details in the show notes as well. With that, I hope you have a wonderful rest of your day. Thank you so much for taking the time out of your busy schedules to talk about Cloud IAM with me.
Yeah,
absolutely. Thanks.
Thank you.